pieces. So it doesn't matter where you put your theta. I'm going to put it right here just because. So in respect to that theta, if I were to locate my hypotenuse, it's going to go right here. Opposite is when I jump, and then the adjacent is right next to. Keep in mind there's two things that are next to, adjacent and hypotenuse, okay? All right, and then for our sine, let's kind of remember our SO, chi, and TOA from Unit 6. Sine is opposite over what? Hypotenuse. Cosine is adjacent over what? Also hypotenuse. And tangent was TOA, meaning opposite over the adjacent. Simply a review. More review on the bottom. I want you to give me the coordinate plane. And I also want you to write 0 degree up to the right. And if I go in a full circle has how many degrees? 360. So let's write 360 is right here as well. And then we go up to 90 here. 180. What's going to go on the bottom? 270. So with that said, let's kind of do a recall of our 45, 45, 90. Because I did tell you guys when we went over the special right, you'll use it for the pre-cal concept, which this is pre-cal concept. 1 root 2. What was the other special right? 30, 60, 90. And let's see if y'all remember. The starting is always a 1. And then, very good, root 3. And then the ending is always some kind of a 2. This one's going to be whole number 2. So with that said, go ahead and turn to your unit circle. Let's fill in what we can. So on our unit circle, let's go ahead and put our angle measurements. So I'm going to write 0 over here and 360 over here. Then I'm going to put 90 up here. And then 180 to the left. 270 on the bottom. Everyone good with that? Okay? Now let's go right in between. What number is exactly between 90 and 0? 45. And what number is a third away from 90? A third away from 90. 30. So that means we're going 30, 60, 90. Here's my 60. Is everyone okay with that? Okay? So then let's go ahead and name every one of them. Let's go by 45 first. If I add 45 to 90, we get 135. Very good. Let's add 45 to 180. 200 what? 45 to 180. 225. And let's add 45 to 270. That's going to end up at 3 how many? 315. Very good. So if you go in sections by 45s, it's going to be easier. Okay? Now let's go by 30s then. If I add 30 to my 90, how many do I get? 120. If I add 30 to my 120, we get how many? 150. Here's our self-check. If I add 30, do I really get to 180? The answer should be yes. So let these be the way to self-check. So 180, when I add 30, we get 2 how many? 210. Add 30 again, we get 240. Very good. Now self-check. Do I really get to 270 when I add 30? The answer must be yes. Now let's add 30 again. It's going to give us what? 300. 30 again? 330. A good self-check. When I add 30, do I get to 360? Yep. Everyone good with that? You have to know how to do that on the test. Okay? From there on, let's go ahead and put in some order pairs. So whatever's on the x-axis and the y-axis, those are going to be called the quadrantals. And that phrase will be used pretty often in pre-cal. Okay? Not a lot in this class. So here's what I want. To the right of it, I want you to give me an order pair. Because I simply went to the right, what value is going to remain 0? I only went to the right. Did I go up or down at all? So x is going to be 1, y is going to be 0. Because I went to the right. And notice it's called a unit circle. Unit circle as in 1 unit. That's why those are 1s. Okay? Now if I go to my left, it's going to give me what as my order pair? -1, comma, 0. Because I went left. Left is negative. If you're good with that, give me a nod. Left means negative. So now go to 90. Give me an order pair on the 90. I went up. I did not go left or right. So we're looking at what? 0, 1. And on the bottom at 270, that's going to be 0 what? -1. Is everyone good with that? Okay? So now let's write something else over here. I want you to give me another coordinate plane. And let's put on here our quadrants. And this might sound a little bit elementary. Quad 1, 2, 3, 4. And then let's put in the order pairs that match. In quadrant 1, everything is positive. In quadrant 2, what is positive and what is negative? If I go to my left, x is negative, y is positive. In quad 3, we have, they're both negative. In quad 4, which one's negative? Good, the y is negative. Okay, are we good with that so far? So then, I want you to write the order pair by labeling x comma y. That's a geometry topic. And then when we go further onto the unit circle, x is a cosine value and y is my sine value. Let's see why that is. Cosine is an adjacent movement, because y'all remember adjacent over hypotenuse. Sine is opposite movement, because it's opposite over hypotenuse. So from there, let's also elaborate. Cosine is adjacent movement. Sine is opposite movement. I am expecting you to remember that automatically after literally 5 seconds. Now let's look at some of the questionnaires. Go to the back of the first page, and I'm going to show you how to use this. Okay, look at number 4. Number 4 says sine of what degree? All right, so at 0. Do we agree that's 0 degree? In my order pair, what's my sine value, 1 or 0? 0, very good. So that's going to be is equal to 0. That part you don't even, oh, it's actually 0 as in the value 0, not degree. Okay, let's do another one. Circle number 9. 9 says cosine of 0 degree. Would you agree that's my 0 degree right here? So from my order pair, what value is my cosine movement? The 1 or the 0? 1. So I'm going to write this one is going to be equal to 1. So are we good with how we use the parts on the quadrantal? Is there another quadrantal on our worksheet? Tangent where? Does everyone say tangent 180? Tangent is the main one that you have to show work for. So tangent is going to be opposite over adjacent. So let's go to our unit circle. At 180, what value is my opposite? 0. What value is my adjacent? -1. Y'all see where I'm getting that from? Opposite over adjacent. Okay? So we have 0. Where am I? We have 0 over -1. What is 0 over -1? 0. Tangent at that point is going to be 0. This might sound a little confusing only because it's brand new, and that is okay. Let your brain kind of process. Is there another one that's on the quadrantal? Anyone see tangent of 90? So tangent of 90. So tangent is opposite over adjacent. So everyone go to 90 degrees. At 90 degrees, what value is my opposite? 1. What value is my adjacent? 0. So you write 1 over 0. Can you divide it by 0 according to your algebra 2 concept? No. What do we call that? Undefined. Very good. You cannot divide it by 0. If the 0 is on the top, that's fine. But if it ends up being on the bottom, it is undefined. So I'm going to circle that as in we did that one together. So can you do the remaining quadrantal on your own, basically? The answer should be yes. Okay? So moving on. I want to worry about 30 degrees. The 30 that I want to worry about is number 1. So let's kind of do this one traditionally. So when I draw my 30 degrees, it really doesn't matter how you draw it, as long as your ratios are good to go. So let's see if y'all remember. What number was opposite of 30? 1. Hypotenuse is 2, and my adjacent is radical 3. And this is simply the review of trig ratio right there. I mean, not trig ratio, special right. Okay? So we know sine is opposite over hypotenuse. So Reagan, what number's on the opposite?
1.
Okay? And what's on the hypotenuse? 2. So it says at 30, my sine value is 1 over 2. So I'm going to go to 30 right here and draw me my order pair. My sine is 1 over 2. So get in the habit of Sine is a y movement, cosine is the x movement. Are we good with that? Now let's see if there's a cosine of 30 on here. Anyone see a cosine of 30 on our worksheet? I don't see it. So let's do it on this side over here. Let's make cosine of 30, because we need it. So cosine of 30, when I draw the image, it's going to look like this. Here's my 30 degrees. 1, root 3, and 2. Cosine is adjacent over hypotenuse. Okay, William, what's on the adjacent? Root 3. Pierce, what's on the hypotenuse?
2.
And that's what we're going to write at 30 on the cosine movement. So here's 30, cosine is radical 3 over 2. All right, something unique happens. If you know one part of the quadrant, you know the rest of them. Let's see how. Y'all ready? Watch where my fingers go. Would you agree 30 and 150 are side by side? Okay, if I go side by side, is the adjacent movement different or the opposite movement different? If I go from here to here, what movement is different? Adjacent, very good. So that means my adjacent is now going to be negative, root 3 over 2, and your opposite movement does not change. That's the beauty of this. When you know one, you know the other one automatically. Is everyone good with that? So now watch what I do next. From 150, I'm going to drop to 210. So I went down, correct? So if I go down, what movement am I going to change? The opposite. So I'm going to leave negative root 3 over 2. The opposite now becomes not positive anymore, but negative. So again, when you know one, you know the rest of them. So then let's go side by side. Point at 210. If I point out 330, what value is going to change this time? Adjacent is going to be what kind of number? Positive. So on here, I'm going to write negative root 3. Oh, adjacent is positive. I'm going to put plus on over here. And opposite movement is still negative because we know the rule for the quadrant 4 is positive, negative. By the way, that should be positive. I should white out that. Okay, everyone good with that? Okay. Now let's go on to 45 degrees then. Let's see on our worksheet. Is there a 45 somewhere? I have right here, cosine 45. Let's try that one. So draw me an angle. 45. It is 1 root 2. Cosine is adjacent over hypotenuse. So Knox, what number's on the adjacent? Should we label it? No, no label. What number's on the adjacent?
1.
Very good. And hypotenuse is radical 2. Are we allowed to have a radical on the denominator? Nope. So we have to rationalize. So when I do, I get radical 2 over 2. So on your circle, let's find 45 degrees. And on my 45 degrees, cosine is my x movement. So let's write on here radical 2 over 2. So here's what I want. On your own, somewhere on the worksheet, I want you to find sine of 45. Go. Write sine of 45. You may redraw the triangle. You may use the same triangle if you want. It doesn't matter. If this number seems redundant, that is normal. And you should be simplifying the radical or rationalizing. Did y'all get the same thing as a cosine? Yep, that's a given fact at all time on the 45. So radical 2 over 2. Okay, time to start pointing. Eyes on the board. I'm going to point. If I point to 45, I'm also going to point to what else? Side by side? 135. What value is going to become negative here? The adjacent. Very good. So we have negative root 2 over 2 and root 2 over 2. So if I point to 135, what am I going to point to on the quadrant 3? 225. So what value is going to become negative now? Opposite. Very good. And someone said both? That is true. Okay, so if I point to 225, what value am I going to point on the quadrant for? 315. What value is going to become positive this time? Adjacent. So we have adjacent is positive, opposite is negative. Is everyone good with that? Okay, so given that, let's see what questions we could answer without drawing any part of it. I want to look at, everyone go to number 17. Number 17 says sine of 150. Look at your unit circle. What value is that sine of 150? At 150? At 150, what's my sine value? What's the opposite movement? 1/2, that's it. Because we did all the work on the unit circle, you don't have to show it on that one. Some you might have to. Okay, what else can we solve at this point? Could we also do cosine of 150, number 18? So if you look at the order pair, the cosine is the adjacent movement. What value was that? Negative √3/2. Do you all see how to use this? Okay, so then let's do one more of the tangent just for practice sake. For the tangent that I want us to practice, that I know it's going to require some work, look at number, did we do 330? Yep. Look at number 15. So on number 15, tangent is opposite over adjacent. Look at your circle chart. Someone tell me what's on the opposite. What number is on the opposite? -1/2, very good. So I'm going to write -1/2 over, someone tell me what the adjacent says. √3/2. So let's recall algebra. When you had a fraction over a fraction, did you multiply by the reciprocal? Do y'all remember doing that? Multiply by the reciprocal at the bottom. 2/√3. 2/√3. And the beauty of this is the fact that everything on the bottom eliminates. So now if I were to move on further, how would I simplify -1/2 times 2/3? I could say -2 over 2/3. Anyone see that? Can I cross off the 2's now? Top and the bottom goes away, right? So I have remaining, I'm going to write up here. -1/√3, and something is not allowed. What must we do further? Rationalize. Good term. So that's going to give us -√3/3, and that's our final answer. The bottom line is tangent is going to require a little bit more work, especially with the radicals. If we're good with that, give me a thumbs up. Okay?